Hello, welcome to our video on differentiation and integration and how they are applied in the real world to solve engineering problems. This video is prepared by the following members. These are the content that will be included in this video. So, what is differentiation? Differentiation is a fundamental concept in calculus. It is the process of finding derivatives of a function. The derivative measures how a function's output changes as the input changes. The derivative of a function is usually denoted as dy over dx as shown here. The main concept of differentiation is to calculate the slope of a tangent line. It is basically like zooming into a graph until it looks like a straight line. These are the different types of differentiation. Each of them can serve a different purpose. For example, high-order differentiation can be used to find the maximum or the minimum point of a function. These are some real-world applications of differentiation. For example, in business, differentiation is used to maximize profit by finding optimal levels of production. And in geography, it is used to study how climate variables change over time.
So here is an example of industry application in engineering. We are being tasked to design a fish tank for a fish farm. Customer has requested the shape of the fish tank to be cylindrical and must not exceed certain dimensions. As engineers, our goal is to maximize the volume of the fish tank with the given limits. By using normal order and high order differentiation, we are able to optimize the volume of the fish tank. Let's assume that the customer wanted the sum of the diameter and height of the fish tank to not exceed 6 meters. So we will have the equation of d plus h equal to 6. Then we make the h as the subject in terms of radius. We replace the h in the equation with the volume of the cylinder with 6 minus 2r. Then we differentiate the equation with respect to r. We will then equate the first derivative to 0 and solve r. We reject r equals to 0 because it's a dimension and it can't be 0. So our value of r will be 2 meters. Next, we will differentiate the first derivative equation and sub in the r value into the second derivative equation. We will then get a value of negative 12 pi. If the value of the second derivative is smaller than 0, which is negative value, we can prove that it is a maximum value. Following with that, we can sub in our r value into the h equation and get the h value. Then sub both the r and h value into the volume equation to get the volume of the fish tank, which is 25.132 meter cube. This is the maximum volume of the fish tank, where the sum of the diameter and height of it does not exceed 6 meters.
Next, we move on to integration. Integration is often considered as the opposite of differentiation. Integration is the process of finding the integral of a function. It is used to calculate the accumulation of quantities and area under the curves. When a function f of x is being integrated, it is represented as such with a and b set as the limits. So the expression gives the area under the curve of f of x from a being the lower limit and b being the upper limit. There are several types of integration, among them indefinite integration, definite integration, improper integration, multiple integration, and contour integration. As for applications, in physics, integration can be used to find the center of mass of an object. In engineering, it can be used to determine the bending moments in beams. In economics, it can calculate growth of an economic variable over time. And lastly, in biology, it can determine the total amount of drug administered over time.
As an example of industrial application in engineering, we are tasked to design a valve with specific design. The customer has chosen wind to calculate the volume of the flask. This is the valve chosen by the customer with a scale of 1 to 10 to its original size. First, the words is traced and drawn on an Excel sheet as shown. The graph is cut into 3 parts to get 3 separate equations to make the calculations less complex. For the first section, we can see that the equation is as shown. Calculate the square of each term. Calculate the cross term and add them together. Calculate all terms into a single polynomial. The squared equation is then integrated with the boundaries of 0 to 6.8 and multiplied with p to get the value of that section. The sum will done with the second and third sections as seen here. To find the total value, we can add the values of all 3 sections together. Then we can multiply the value with the green scale, which is 1 to 10 to find the actual value of the values, which is 13.39 or 13,492.22 cube.
So, these are just a few examples of how differentiation and integration is used in the real world to solve engineering problems. Thank you for watching.